Welcome to Study Loop.
So let's draw the picture first. Let's say this one is the nut, and here is the wrench. The force is acting this way, which is 17 newtons, and the angle between the wrench and the direction of the force is 37 degrees, and the length of the wrench is 25 centimeters. Now to figure out the torque, we can use torque equal to R cross F. Also, we know that R cross F is nothing but RF sine theta, where R is the radius vector, theta is the angle between force and the radius vector. In our case, the direction of the force is this way, or towards the left, and the radius vector is from the nut to the end of the wrench. So the value of R is 25 centimeter, and the value of force is 17 newtons, and the angle between the radius vector and the force is 37 degrees. So we can use all the values here and then solve for the torque, so which is 25 centimeter. Then we have the force as 17 newtons. Then we have sine 37 degrees. Using all the numbers, we see that torque is 2.56 Newton meter. And for the direction, the torque will be counterclockwise because we see that force is this way. So if we curl our fingers from radial vector to the force, we see that we'll have a counterclockwise direction. Now for part B, we need to find out the maximum torque. So the maximum we'll get max. So we know that the radius vector and the force is constant. We cannot change that. But the one thing that we can change is the direction of the force by changing the angle theta. So we know that sine theta is maximum, or the maximum value of sine theta is 1 when the angle theta is 90 degrees. And because sine theta sine theta has a range of -1 to +1. So that's why the maximum value that sine theta can have is 1, and that value is achieved when theta is 90 degrees. So that means instead of 37 degrees, if we direct the force perpendicular to the radius vector, then we'll have, let me use a different color there, like this way. So then we'll have the maximum amount of torque. So for the maximum amount of torque, let's call it tau max. That will be just the multiplication of the radius vector and the force vector, because sine theta becomes 1 in that case. So 25 centimeters, 17 newtons, which gives us the maximum torque as 4.25 Newton meter. Thank you.